Okay everyone, let's start with the question number 3 for this video. This question is derived from the topic 3 geometry and trigonometry section. So let's read the question together. It says that we have a monument which is in the shape of the right cone with a vertical height of the 20 meters. And Oliver stands 5 meters from the base of the monument and his eye level is 1.8 meters above the ground. Right? And then the angle of the elevation from the Oliver's eye level to the vertex of the cone is 58 degrees, as shown on the following diagram. So here we have a diagram, and we do know that the vertical height of this right cone, which is this part here, is 20 meters, and the Oliver's eye level is 1.8 meters above the ground. That means we can say from here to here is 1.8. And since we know the vertical height of the right cone is 20 meters, then the length between this vertex of the cone to the eye level of the Oliver is same as 20 minus 1.8, which is same as 18.2 meter. Okay, then we also know that the angle of elevation from the Oliver's eye level to the vertex of the cone is 58 degrees. Okay, then using this information, let's start with the question A. So question A, we need to find the radius of the base of the cone. So means we need to find the radius here. Okay, we do know that the distance from the center to the Oliver is same as radius plus 5, and which means it's also same as the length of this line here, right? That means since this line can be also the base of the triangle, I mean, you can definitely see there's a triangle forming here, right? The right angled triangle, right? So let's redraw this triangle. And we have right angled triangle, right? And we do know that this angle here is 58 degrees. The length between this vertex and this point here is 18.2. And we do know that this part here is same as the radius plus 5, right? We're referring to this part here. Then we have a right angle triangle. And what we're trying to do is we're trying to find the radius. That means let's try to find the length of this side here. Okay, we're going to call this length as the base. Okay, then or we can also say that since we are going to use the trigonometric ratio, and then using this angle as our pivot angle, we do know that the opposite side from this angle is opposite side. The neighboring side is adjacent. So let's call this side here adjacent side, and then we have a hypotenuse, right? And then we do know that adjacent is actually same as radius plus 5 meter, right? Then using the trigonometric ratio, I'm going to use tangent, right? So if I say tangent 58, and this is equals to opposite over adjacent, right? Or we can also say this is same as 18.2 over adjacent. Okay, then using calculator, we can calculate the adjacent value as 18.2 over tangent 58, which is same as, okay, then using your calculator, here I have a TI-84 calculator, right? So we can do 18.2 divided by tangent 58, then we get 11.37. right? Then we have 11.37. Then we do know that adjacent is same as radius plus 5 and is equal to 11.37. That means radius is same as 11.37 minus 5, which is same as 6.3726, right? And since we have to leave our answer in specific, we can say that our answer, the value of the radius, is same as 6.37. Then question B, we need to find the volume of the monument. So question B, since the monument is in the shape of the right cone, we're going to use the formula of the right cone, which is from the page 5 of your formula booklet. It says the volume of the right cone. And the formula that we're going to use is the V equals 1/3 pi r squared times h. Okay, then using this formula, V equals 1/3 pi r squared times h. We do know that 1/3 times pi, the r value is 6.3726 square. We're going to use the value before we round it up, okay? And times the height, which is the 20. Then we get our value 850.540. And same, since we have to leave our answers in specific, the answer will be 851. Okay, everyone, then let's try the question number 4 together. So as you can see, this question is derived from the topic 4, statistics and probability section. So it says that the random variable x is normally distributed with the mean value 10 and standard deviation 2. So question A, we need to find the probability that x is more than 1.5 standard deviation above the mean. So question A, what I'm going to do with this question is I'm first going to draw the diagram. So we can say this is my diagram, okay? And then we do know that the mean value is happening here, so 10. Then mean plus 1 standard deviation is same as 10 plus 2, right? Then it says that we need to find the probability that x is more than 1.5 standard deviation above the mean. So the phrase x is more than 1.5 standard deviations above the mean means that the value x is greater than mean plus 1.5 standard deviation. So finding the probability that x is more than 1.5 standard deviations above the mean means calculating p x is greater than mean plus 1.5 times standard deviation. Okay, then using the mean value 10, standard deviation value 2, we can rewrite this as p x is greater than 10 plus 1.5 times 2. Then this is same as p of x is greater than 13. Then using GDC, we do know that this is GDC paper. It means we can use GDC, right? So using GDC, we're going to press second bars, and we are going to use normal CDF. Okay, and we're going to set the lower boundary or lower bound as 13 and upper bound as 1 to the power of 99. Okay, just to show that we are using very large number to represent the infinity, and then the mean value 10 and standard deviation 2. Okay, let's put this on the GDC. So I'm going to do second bars, and I'm going to select number 2, and I'm going to set my lower boundary as 13 and upper boundary as 1 to the power of 99, and I'm going to set my mean as 10 and standard deviation as 2 and hit enter and enter. Then I get 0.066807. So my value where that x is more than 1 point standard deviation above the mean, so the value of the probability is same as 0.066807. However, I have to leave my answer in specific, right? So I get the probability that x is greater than 1 point, or the x is more than 1.5 standard deviation is same as 0.0668. Okay, then let's try the question B together. So there's extra information here. So it says the probability that x is more than k standard deviations above the mean is 0.1, where k value is all real numbers. We need to find the value of the k. That's the question B. So what this question implies is the place x is more than k standard deviation above the mean means the value of the x is greater than mean plus k times standard deviation. So this means finding the probability that x is more than k standard deviations above the mean means calculating probability of x is greater than mean plus k times standard deviation, and we do know that this is equals to 0.1, right? Then to calculate this question, what you want to do is let's simplify this part first. Okay, so mean plus k times standard deviation. So mean value is 10 and standard deviation is 2, so it's 2k, right? So we can rewrite this equation as probability of x is greater than 10 plus 2k equals to 0.1, right? Then let's check this equation with the z-score, okay? So using the z-score formula, which is, you can definitely skip this step, right? But I'm just going to show you the reasoning behind this question's solution. So we know that this is z-score formula. And then we do know that from here that x is also possibly equals to 10 plus 2k, right? Then substituting x equals 10 plus 2k into this z-score formula can give us the z equals to 10 plus 2k minus mean, which is 10 over 2, right? That means this is equals to 2k over 2, which means this is also equals to k, right? This means since the probability of x greater than 10 plus 2k is equal to 0.1, we can find the z-score corresponding to 0.1 in the upper tail, right? Then to calculate the z-score corresponding to 0.1 in the upper tail, what we're going to do is we're going to use the inverse function on the TI-84. So step 2, I'm just going to say this is say step 2, and this is as my step 1. You can definitely skip the step 1 part, right? So step 2 is finding the z-score for 0.1 in the upper tail. In order to identify the corresponding z-score, we're going to press second bars. Okay, and to open the district menu, and then we're going to select the 3 inverse norm. Okay, and we're going to enter 0.9 as our area. Okay, some of your calculator can definitely use the 0.1 right away. In that case, if you're using your area as 0.1, sometimes you have to choose your area, and in that case, it is a right area, right? Or if I'm drawing the diagram, we do know that this is our k value, and this part is 0.1, and this part here is 0.9. So that's the reason why if we choose area as 0.9, then we have to choose left. Okay, so what I meant by this is, let's go to the calculator. So we're going to go second bars, and we're going to choose inverse norm, and we're going to choose area as 0.9, and then mean as 10, standard deviation as 2, and then we are going to choose left as our tail, and then hit enter. Then you get 12.56. Okay, so we just found the 12.563. This value here is equal to the z-score value that's corresponding to 0.1 in the upper tail, right? So it means it's referring to this part here. So 12.563 is actually same as mean plus k times standard deviation. Okay, because we found the z-score corresponding to the area in the upper tail, it doesn't mean doesn't mean that we are referring to this part. Okay, this part here, step 1, is just the step to show that we have to convert to the z-score to figure out whether we are finding the z-score corresponding to 0.1 in the upper tail. So, as I told you before, this step you can definitely skip it, right? Don't worry about this step. But what we know so far is what we have found with the inverse norm function is the part that's inside the bracket and is referring to this part because we are trying to find the k standard deviation, right? So 12.563 is equal to mean, which is 10, plus k times 2. So we can do 2k equals to 12.563 minus 10, which is same as 2.563, right? Then dividing both sides by 2 give us the k value, which is 1.2815, so on. And that means since we have to leave our answer with 3 suffix, right? The final answer is k equals to 1.28. And we have found our answer.